Hello and welcome to this session on solving absolute value inequalities. Let's start by looking at the form of an absolute value inequality where we will see a less than symbol or a less than or equal to symbol. So if you're given something in this form, what it really means is that in order for the absolute value to be less than 3, it has to be within 3 units of 0. You can see from the graph below how that would appear. If you were to use some test points, you could plug in a -2, -2.5, anything in between these integers, and it would make this inequality true. The interval notation, because it's from -3 up to 3 and not including either endpoint, would look like this. And then the algebraic notation is that second line, -3 less than x less than 3. If you were to have something like an expression that's a little bit busier inside of the absolute value bars, like x minus 5, this would mean that the distance between x and 5 is less than 3. So according to the graph, anything between the 2 and the 8, if you plug that in, it'll make that inequality true as well. What you've noticed from these two inequalities is that the less than symbol appears to create a number line graph that is, it doesn't go into infinity off to the left or to the right. So if you come across an inequality that uses the less than or the less than or equal to symbol, then here are your steps for how to solve it. The first thing you always want to do when dealing with inequalities is to the first thing that you want to do is put that inequality into standard form. Standard form is when you have the absolute value all by itself on one side of the inequality. Both of these examples in step 2 are in standard form already. There's nothing being added or subtracted or multiplied or divided on the outside of the absolute value bars. They're all by themselves. Okay, once it's in standard form, and it has a less than symbol, you will rewrite this inequality as a 3-part inequality. The middle of the inequality is the expression that's inside the absolute value bars, except you are dropping the absolute value bars. The symbols, the inequality symbols, are the same as what you started with. And then the left and the right boundaries are a negative and then a positive of whatever this inequality was less than. The same thing happens if you have an expression. You would put that expression in the center, drop the bars, and then you have less than and, you have a negative and a positive of that value that the absolute value is less than, excuse me. So let's solve a couple of these. Okay, so the first one here is already in standard form. It's completely simplified, and because I see that it's got a less than symbol, I'm going to put what's in the absolute value bars in the middle. I'm going to use the same inequality symbol and then a -6 and a +6. So this is the algebraic notation. From there, you're typically asked to give the interval notation and the number line. You can do either one first. The number line, we would need to show the -6 and the +6, and then it's, as we noted in the examples to start with, it's typically, it's always going to be between those two. Otherwise, we wouldn't be able to write a 3-part inequality. The interval notation then looks very similar, and there's parentheses everywhere. For the second example, we notice that it's a less than or equal to, so it's going to work the same way, and it's got the absolute value, so I'm going to just copy that, dropping the bars, use the same less than or equal to symbol on either side, and then a 5 and a -5. To solve a three-part inequality, your goal is to leave the variable in the center. And just like you have to do the same thing to both sides of an equation, you have to do the same thing to all three sides of a three-part inequality. So I'm going to add 4 in all three sections. So that'll leave me with a -1 less than or equal to x less than or equal to 9. That is the algebraic notation. On a number line, we're going to need to use brackets because of basically the or equal to aspect, and all values of x are between these two numbers. Oops, that should be a bracket. Sorry about that. And then, of course, shade in the center. So your interval notation, bracket -1, comma, 9, bracket. Okay, the first thing you should notice about this one, other than it's got absolute value bars and a less than symbol, is that it's not in standard form. You have to get it into standard form before you really consider what whether it's even going to really use a less than symbol. You could end up having to divide by a negative or multiply by a negative, and that would flip your inequality symbol. In this case, all we have to do is add 7 to get the absolute value by itself. So I'm left with the standard form. Keep in mind that standard form does include the absolute value bars. Now, once it's in standard form, I can tell, yes, it is absolute value using a less than symbol. One way to view this is simply to rewrite what you see except without the bars, and then you can go back and add on the extra symbol and the -11. It's the same idea. Okay, so now I'm going to solve this by first adding 9 everywhere. We have to take care of the addition and subtraction before we do anything else. That's called the addition property of equality. And then I'm going to divide by 2. If I had been dividing by a -2, I would have to flip all of the inequality symbols. And we have our algebraic notation. Both of these have the or equal to, the straight line underneath, so that means I'm going to use a bracket. Both the bracket and the parentheses should be right on that endpoint, even though with parentheses it doesn't include it. Okay, and then the interval notation, brackets on both sides, and make sure that your order is always going from least to greatest. The second half of this lesson focuses on inequality symbols that are greater than or equal to, and of course have an absolute value before that. So standard form is very similar, or it's the same thing. You still want to have the absolute value bars included. Here is a representation of on the graph of how one of these would look. You can see that they go in opposite directions. The reason being, if we just look at this simple example here, in order for a number to have an absolute value that's greater than 3, then that means its distance from 0 has to be greater than 3. So absolute value is all about the distance from 0. So anything outside of 3 spaces from 0 would make that inequality true. The interval notation you can see is made up of two intervals connected by a union symbol. The union symbol looks like a U that's kind of been stretched out. So you basically just do an interval for this side, do an interval for this side, and connect them with a U. The algebraic notation is similar, except you connect the two algebraic notations with the word or. Okay, please keep in mind that because you've got these two separate pieces, you'll never be able to combine it into one inequality. So that's why we're going to have a different list of steps for solving absolute values of the form that use a greater than symbol. And here they are. So if you've got greater than, and yeah, the first thing you want to do again is put it into standard form. And both parts A and B are really the same thing. What you want to do is write two inequalities connected by the word or. The first one is the same as what you've been given except without the bars. The second one is involving flipping the inequality symbol and changing the sign of the value for C. So you can see the same thing is happening down here. Okay, we notice that because it's a greater than symbol, we have to use or, but we have to break it into two inequalities. The first one is basically rewritten without the bars. The second one, you have to flip the inequality symbol and change the sign. Okay, so no matter whether it's something simple like just X, or you've got an entire, a busier expression. Okay, here's a few examples. So the directions say to solve the inequality. They want the solution set in interval notation and then also on a number line. In order to get to either one of those, you have to solve it into algebraic notation. Okay, so when you see the greater than symbol, one way you can remember that you need to use or is basically by mispronouncing or misspelling the word greater. Instead of ER, you could think of it as great or. So great or than reminds me to use an or. All right, so it's already in standard form. I'm going to rewrite it without the bars for the first one. And then the only difference here, and I'll highlight it using a different color, we flip the symbol and we change the sign of that value. And there you have it. So from there, we just continue bringing down the word or, and we solve each inequality separately. So that means I'm going to add 4 to both sides, giving me x is greater than 10. Adding 4 over on this one gives me x is less than negative 2. I recommend doing the number line initially because that will definitely alert you. Well, if the or hasn't already alerted you that you might have to use the union symbol, then the number line certainly would. There's cases where it, when you do one of these greater than problems, that it would be all real numbers. And so that would be more, it'd be easier to see if you've already graphed it because the whole line graph would be highlighted. In this case, let's see what happens. X is greater than 10, so that will be a parenthesis and shade to the right. X is less than negative 2, a parenthesis and shade to the left. Okay, so you can see that there's a space in the middle here, so I'm going to use a union symbol and do the interval notation for the left side, which is negative infinity up to negative 2, not including negative 2. And then the right is similar, but starting at 10 and going to positive infinity. It's very important that you keep those in order all the way across. Every single piece here is in order on a number line. You've got negative infinity, that would be less than the negative 2, which is less than the 10, which is less than the infinity. And that's easy to do once you've already seen how it looks on a number line. If you go straight from algebraic notation, it might be more difficult because they're not necessarily in the order that you would see them on a number line. Okay, let's solve another one. Okay, and here's that second problem. It just gave us a little bit more room. First things first, make sure you get it into standard form. So I've got to add 5. Now at this point, if you are tempted to multiply that 3 into the absolute value bars, please don't do that. Absolute value bars don't behave like parentheses. You can never distribute into absolute value bars. And some of you might be thinking, well, I've done it before and gotten the right answer, but it doesn't always work out like that. You might only get one correct answer and the other point is incorrect. So to get rid of it, you need to divide it out on both sides. Okay, so we'll have the standard form, absolute value 4x plus 5, greater than or equal to 5. So from here, you note, okay, I have absolute value bars, I have a greater than symbol, great or, I need to break it into 2 inequalities separated by the word or. The first one is basically copied without the bars. And the second one, you're going to have to flip your symbol and change the sign of what's on the right. Oops, and I did not flip my symbol. Okay, less than or equal to negative 5. And now solve. So I will subtract 5 from both sides. Divide both sides by 4. 0 divided by 4 is 0. Negative 10 over 4 will reduce to negative 5 halves. Just to save room, I'm writing it out to the side. Okay, so our number line needs a 0 and a negative 5 halves. 0 is greater than, or I'm sorry, x is greater than or equal to 0, so that's a bracket going towards positive infinity. And x is less than or equal to negative 5 halves. Okay, so you've got the 2 pieces with a gap in the middle, so that's where you're going to use the union symbol. You can feel free to rewrite that fraction as a decimal or a mixed number. Just pay attention to whatever the directions are requesting. And there you have it. Okay, just a few more examples of some special cases. So we're mostly going to be talking about these. So looking at the first one, the first thing you notice, it's already in standard form, it's got absolute value bars, and it's using the less than symbol. So normally, you're thinking, I should write this as a 3-part inequality. If you start writing it as a 3-part inequality, and I'll do it in a different color because this really is not the way you want to do it. Okay, so I'll put a little sad face here. You could waste your time and do something like this. And hopefully this will be enough for you to catch your mistake. 2 cannot be less than negative 2. So it just doesn't make sense to start with, and even if you try to flip this around, you'd have to flip the symbols with it, and it's just not going to work. The reason it doesn't work, as I'm sure you've already noticed, is that absolute value cannot be less than a negative. It can't be negative, much less than a negative. So what this means is no matter what you plug in for x, you're never going to get something that's less than a -2 because you end up taking the absolute value of it, and that's always positive. So as soon as you notice you have absolute value less than a negative, you can say no solution. Okay, the empty set would be another way to describe that. The symbol for no solution is a 0 with a line through it. If you were asked to graph this on a number line, it would just be an empty number line. And set notate, well, there's so many notations. We'll leave it at that. Okay, over here on the second example, we kind of know what to look out for. It's saying that it's greater than a negative. Absolute value is positive in general, always. So that means that you can basically look at this as, okay, I have a positive number greater than -8. How often is that going to happen? Ask yourself, is that true? Yes, it's true all the time. So you can plug in any number you want into x. You're always going to get a positive number. So all real numbers will work. You can write out all real numbers, all the words. I just ran out of room. You can maybe select a symbol or write this down. The interval notation is sometimes requested. That would be from -infinity all the way up to positive infinity. That should be a parenthesis on the right and the left. And then the number line would just be completely shaded from -infinity up to positive infinity. The last example we're going to look at is just one involving some fractions. Let me change my pen color. Okay, so in the thing about this problem, and the reason I want to show it to you is some of you already know how to reduce the 6, the 3, and the 3 on the left. Technically, we haven't learned how to factor out a greatest common factor and reduce, so I'm going to choose to skip that process and stick with the order of our curriculum as it is currently. First thing you need to do is get it into standard form. Now that it's in standard form, you see that it's an absolute value that is less than something. So that means you can write it as a 3-part inequality. So you basically rewrite it without the bars, and then on the left use the same symbol, but change the sign of the value to the right. At this point, you need to clear the fractions to be able to get to y. To clear fractions with equations, you have to multiply the entire, both sides entirely by the least common multiple. There's only, the denominator is simply 3 here. That's the least common multiple of all of these, so that's going to be multiplied to all 3 parts. So I'll have -15 is less than 6y plus 3 because the 3's canceled out, is less than 15. And now you're kind of home free here. You need to subtract 3 from everywhere, all 3 parts. And then divide everything by 6. And there is your algebraic notation. On a number line, we'll use parentheses, and of course all the values are in the middle, just like how it's in the middle on the algebraic notation. Oops. Your interval notation, parentheses, -3, 2. Parentheses. Thank you, and this concludes your session on solving absolute value inequalities.